Table is graph y equals x squared minus 2x minus 3 and fill in the table and sketch the graph. So you should be able to do that without any problems, and if that's a struggle for you.
Graph what?
Huh?
Graph what?
Oh, I'm on the
Okay. Came in right on time.
square.
You're supposed to work with the lady table. You may need a calculator. Put that in a calculator, and you're filling in the table and sketching the graph. And left. You should have your Brooks class, your notebook.
Oh, yeah.
It's pretty much it.
Wait, so he was not in honors, now he's in honors? How come you weren't in honors?
Upgrade.
Remember, to see a table, you press what?
Control T.
Control T.
Anyone shocking? Very good. Give me a pencil with that.
Why do you have to do
It's not
a problem.
Anybody have pencil before?
Negative 3 and 5.
You missed it.
Hey guys, read the paper. It says it only wants the values between negative 3 and 5. So you're filling in negative 3, negative 2, negative 1.
Yeah. A little graph.
So those are the values you're looking for.
Hey, Mark. Can you pass me calculator 20, please?
I said no.
Give me a calculator. Hey, Miss, where you calculator all scratched up?
Huh?
Your calculator all
I know. I don't know how people are scratching them up.
Drop them.
Bring Eric one too. Or bring Brittany one. Guys, this is just basic graphing and reviewing of tables and graphs. We shouldn't struggle here. I shouldn't have to do much here.
Can you help me, please?
You just put it in the calculator.
But what are you supposed to put? That?
Yeah, and then you do the little. You do control T to look at the table.
It's frozen. Why is that right here?
What's wrong?
The graph looks different from one graph.
Because there's a wider version of it?
No, I mean like, right here it says 1, 4 is the lowest, but then you graph negative 2, 5.
What's greater? What's smaller than negative 4 at the y?
Is this a negative number? Is this a negative number?
Anything else smaller than negative 4?
Oh, I went the wrong way.
Does that be my first name?
Huh?
Does that be first name?
No, it's a sketch. Put it up, Trevor.
Oh.
No, Trevor.
It's not messed up.
You want to see my schedule?
No, Trevor. You were on my attendance.
Money got. Did you want to make sure?
Did you mark me in here?
Yes, Trevor. Because I knew you were here. I just knew where you were. So I came and got you. All right. Once your table has completed the table, please send someone from each table to fill in 2 of the blanks.
Oh,
Two of those blanks?
Yes, 2 of the table blanks.
all right.
I want to. Nah, I want to.
Too bad.
I need 2 holes.
I'm over here like sketching them when I can touch on. Zero negative 3. It's supposed to be later.
Come on with 3, go fit in 3.
Wait, what? What are we supposed to fill in? Alright, you're supposed to do it with the little pen.
Oh, alright, I'll be alright then. Hey, no, let me raise my zeros because then I don't remember where they were. Gracias. I filled in my hole. Holes.
Should be like 12. One's left for one person, I think. Well, this class will
Alright, these are the values you should have gotten. Did we get them?
Yeah.
Yes.
Did you sketch your graph?
Yeah.
Oh.
Do-do-do.
Right there.
Is it -3? Can't see it. And then 0?
3, 0.
My head's in my way. And then 5? Is that right?
I don't know.
And then after 5s are 12s, which are off the page, so. That's a horrible illustration that I just did.
I like your VU.
Just pretend that it goes through all points. Okay, I'll redo it.
I can't see the point.
Oh, whatever. You know what it looks like. All right, so what we should be able to identify from this is telling us that regardless if we have a table or if we have a graph, the key things we should be able to identify are vertex. Our vertex should be something we can identify. So, what is my vertex? -4. Okay? If I'm looking at the table, it's the one that has the smallest what value? The one that has its smallest y value. Well, in this case, not the y value. I'm sorry, that's a lie. It's the one where, if I look at it, that's where my pattern, my reflection begins. So at -4, this is where my reflection starts. So if I'm looking at a table, I'm looking for the point where the reflection begins. Do we see it?
Yeah. Yes.
Okay. If I'm looking at the graph, I'm just simply looking for my lowest point. Or if it's a maximum, I'm looking for my
Maximum point.
my highest point. Yes. Good job. All right. Okay, and when it says when the graph turns, that means that your graph is going from either increasing to decreasing or decreasing to increasing. Okay? So what that's called is when your graph is increasing and then it decreases, this is called a maximum. When your graph decreases, then increases, this is called a minimum. Got it? Hmm?
On the y part, it's in line
So, it says, how do you think would call this point a maximum or a minimum? What would this be? A minimum, because what is our function doing?
Decreasing, then increasing.
It's decreasing, then it's increasing. The other way to look at it is if you're looking at a table and only a table, if it's a minimum, that means it's the lowest y value. And when we look at our table, is -4 our lowest y value?
Yes.
Yes. So when you're looking at a table, it's going to be your lowest y value on the table.
It's lowest y value.
Y value on the table. If you're looking at a graph, you're looking to see what is happening to your function. If your function is decreasing, then increasing, that's a given that you're dealing with a minimum. India, you got it? India? All right, now we're on to the graph is a symmetrical to the vertical line through the vertex. So we're going to draw a dotted line through our vertex.
So we go straight down to the 1.
Yes, so our dotted line is going to go down the... If on your test or on a quiz, it asked you what is the function, what is the equation of your line of symmetry, what should you say?
X,
There you go.
equals 1. Oh.
So my equation for my line of symmetry is
X
x equals 1. And remember, we talked about this with Vux and with Oi Vux, right?
Yeah, wait, fuck.
Oi Vux.
The fuck. I don't even remember that.
Okay. When we talked about Oi Vux means that if it's a horizontal,
Or Y.
it goes through the y-axis.
Y. Oh, vertical.
If it's vertical,
X.
it goes through the
X-axis.
x-axis.
What's
And
U?
huh? This represents it has an undefined slope and it has a 0 slope. Oi Vux.
Fuck.
Vux. Stop saying with the F.
What are you talking about? I said fucks.
All right. So because this is a vertical line, we know that our variable that we're using has to be x.
You want us to leave it like that?
What is the O?
What?
We just put more, we put horizontal.
Is it so?
Or you could just write or.
Four.
Or,
I mean,
the H.
Hori? How about that? Is that better? It's the best we're gonna get, guys.
Got the Z.
I don't feel like writing the rest. Okay, you can write horizontal on your paper.
Unless you're Trevor, if you want more.
All right. So we understand that? So if on your quiz or on your test it says identify the equation for the line of symmetry, it should always be x equals the number, right?
What's the O again?
O stands for 0 slope.
Oh, yeah, that's right.
What is it under the?
Huh?
What does it say under the?
Slope. It's really hard to write. Huh? All right, here we go. On to the back.
Hold on, what is much mean?
Vux, vertical, undefined, x-axis. What point is the y-intercept? 0, -3. How do we know that?
X is 0.
Okay, it's when you're looking at the graph, it's when it crosses the what axis? The y-axis. When you're looking at a table, it's when what?
When it crosses the X-axis?
On a table, it's when x equals
0.
Okay, so those are your two ways to identify your x-intercept. When it crosses the y-axis, and on a table, when x equals 0. All right, so keep that -3, huh? It is, as a board protractor. When you look at -3, and you look at the equation we had, so our equation is what? Y equals, what's the equation, guys?
X squared minus.
X squared
Minus 3.
minus 2x
Yes, minus 3.
minus 3. What do you notice about that number?
It's in the same place as a Y
B
intercept or
intercept.
slope
B.
intercept.
Exactly. So what this tells us is our constant value is our
Is our
what?
Y.
There you go.
Y-intercept.
Constant is the y-intercept. So when your equation is in standard form, the constant, which is the number that's by itself, is the y-intercept. So if I gave you an equation, you should automatically be able to tell me what my x-intercept, my y-intercept is.
Yeah, why is it made?
It's a y. I think that's a really good y I made.
No.
Which Y?
How you know?
This one?
Yeah, that is B.
Man, how you?
Which ones and 5?
What?
Y equals
Man,
2. Y equals x squared minus 2x minus 3.
it's on your paper.
It's on the other side.
How'd you get it? Man.
All right, what if I don't have a constant? What does that mean my y-intercept has to be?
0.
0. So that means I go through the
0.
origin. Origin.
Yeah.
All right, next it says what point has the same y-coordinate but lies on the other side of the x-axis? What point has the same y-coordinate but lies on the other side of the x?
0.
-1, 5,
There's 0.
There's gonna be 2 points.
No.
Oh,
Isn't it -1?
2, negative 3.
Oh, 2, negative 3.
Has the same y value.
Oh, see, I was right.
Negative 3, 12.
So it's 2 points.
Oh,
This,
man.
all of them have the same y value.
Yeah.
They don't have all the same y value.
Yes, 0,
Negative 3
0,
and negative
5, 5.
And 12, 12.
No, it says which one has the same y value as your y-intercept. That's what.
No, what's that?
Then shouldn't it be negative 3 then?
Did I read it
It
wrong?
says what point has a y coordinate, but it's on the other side.
That's the same
the
y.
axis-
Because we're talking about the y-intercept. Sorry.
Oh, it's talking about.
It's still talking about the y-intercept. So talking about the y-intercept, I don't.
0, 3.
If we have 0, negative 3,
2, negative 3.
did I write it back?
Get it.
Why is this lost? Yeah, I thought it was negative 1 by
You notes are bad.
But yeah, because the axis, it's 2, negative 3. No.
I thought it was negative.
Pause. Pause on life. Literally. Okay. I'm sorry. Our, what do you call it? Our y-intercept is at 0, negative 3. What is the opposite, or what's on the opposite side of the
3.
3, 0.
2, negative 3.
2, negative 3?
Negative 3.
That was me.
How do I?
If the problem asks for what was the point on the opposite side of the line of symmetry that had the same y value. So it would be 0, negative 3, and 2, negative 3. They're on the opposite side. Huh? Mm-mm. Because it wanted to know what was the opposite of your y-intercept. Okay, so what this is telling you, the reason why I asked this is because if your y-intercept is not the vertex, there is a point symmetrical to it. Okay? So if your y-intercept is not the vertex, there is a symmetrical point. But if my y-intercept is the vertex, then there is not a symmetrical point. It works vice versa.
Alright. Not the vertex. There is a symmetrical point. Because if it is a vertex, then it's on the line.
It's the line of symmetry.
Got it.
Is this supposed to be a symmetrical point or what is symmetric?
You know, math is my strong suit.
Not words.
So I probably should write a point symmetrical to it now that I did not write that. If we want to be grammatically correct. And if we really want to be grammatically correct, I would have to calculate that. But
And yeah, you need to capitalize that. And then if you want to be grammatically or
Grammatically.
or whatever it is, you put a
You can't call them
after
after
vertex.
I don't think you have to.
Yes, you do. But they're separated two things. Because one is 9, the other one is. Keyword.
And yet you would do that to us because it's math. Why do we care about
I don't know. Thank you, Eric.
She wasn't at all.
All right. I never said I was good in English.
Miss Fair, look at your glue.
It happens. All right. There are two x-intercepts. What are they?
Negative 1, 0.
-1, 0, and
3, 0.
3, 0. So an x-intercept is when what? When is it? Graphically, x-intercept is when what? When it
Y0.
when it crosses
The x-axis.
the x-axis. Table-wise, what is it?
AT,
Y
y
is
equals 0.
0.
Yes, Trevor. I do not have pretty handwriting like Miss Brooks, so
You don't have a problem with what?
I don't have pretty handwriting like Miss Brooks.
Pretty handwriting.
So sorry.
I noticed.
Never have, never will.
Who said that? You're never too old. Wait, no, you're like 25.
Priscilla has
Am I right? You're like 25.
Give it a
Alright, now we're going to go back into factoring. So it wants us to find the factors. So we have x squared minus 2x minus 3.
2 and 3.
Well, how would I factor this?
Oh.
My a equals 1, so I could do what?
You divide by x.
Find the factors of C that equal B.
Mental.
I can mental factor,
You
right?
can't.
So what times what gives me negative 3, but adds to give me
Negative 1 and 3.
Negative
Negative 3
1.
and 1.
negative what?
3 and 1.
Negative 3 and 1.
Because it gives you negative 2.
Okay, so my factors are negative 3 and
Positive 1.
there we go. We have now mental factored it. Okay, let's recap mental factoring.
Did you get that, Trevor?
You roasting?
Mental factoring is if my leading coefficient is 1, that means I only pay attention to these two numbers, my B and my C. So, what multiplies to give me negative 3, but adds to give me negative 2. So, negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So, therefore, they are my factors.
I'll try to do that on all of them.
Got it?
Oh, wait.
Alright, so what do you notice about these factors and my x-intercepts?
They're two different colors.
Besides the color,
The x's are not the same.
They're opposite.
they're the opposites. They're the same. The reason why they are the same is because if you have the function, in order to find your x-intercepts, all you do is take the function and set them equal to 0. Because if we're setting them equal to 0, that's our y value, right? We want to know when does y equal 0. So if we want to know when y equals 0, then we take our factors, and I wrote plus 3 and not negative 3, and no one stopped me.
I was going to say that, but you kept on talking, and then you could be like, you don't even let me finish.
Okay?
Girl.
So, when you do that, now you would solve for x, and that would give you your intercept. So if I was to solve for x, what would I do?
3. Oh, you got to subtract 3.
Not subtract 3.
Add 3.
So x has to equal
3.
3. And does x equals 3 here?
You didn't know? Yeah.
Boom.
Oh, yeah.
What would I do here? Minus 1. And so x has to equal.
Negative 1.
And does it equal?
Yeah.
Yes.
It does. So therefore my x-intercepts are negative 1 and 3. So I can either find it with a graph, with a table, or with a equation. I can do it all. And hopefully you guys wrote down your essential question for the day on your Cornell notes.
Oh, yeah.
Where are they at?
If you didn't,
What happened? Where are they at?
You got to take Cornell notes.
Says they're in those.
I haven't cut them.
Oh, see.
You can get one page per table.
Hey, hand me one.
Okay. What are you supposed to do?
Hand me one, bro.
They're going to explain to you.
Oh, we are.
That's what a best friend is for, right?
I get it.
You can take one.
Hey, bro, I got it, bro.
Essential question.
You only need one per table, Noe,
Table, I got
Go
it.
ahead, read it.
where it says essential question.
Three of them.
How do we cut
You
it down?
split it.
I didn't do it. Oh, yeah.
What's the objective?
Your objective? What you're going to learn? What you're going to learn?
Oh, yeah.
Being
So
careful.
what you do is you write your question on the corner notes, and you take one question from the thing, and you answer it on the summary.
Girls, are y'all going to explain to Trevor what Cornell Notes is?
You already- I know what
Or what's required
Hey,
in
man. Quit trying to get attitude.
color it is.
Alright, here we go. Let's finish. And then you'll have time to do your Cornell Notes. Alright, how can the x-intercept be used to determine the factors of quadratic equations? Write a generalized rule. Oh, I wrote it. Oh, we're going to write it in words. Alright, so writing in words, how would we say this? We take the what and set it to what?
You guys determine every day?
You take, oh, you take the
What were these?
x-intercept and set it to 0. The
Huh?
factors,
How would we do that?
you set them to 0.
Yeah.
What are we doing? We're still on notes?
Yeah.
That's like a lot of notes.
You have the exact same ones today in her class.
Yeah, but y'all take more.
But they don't even finish their notes. They just go to the work.
How can the x-intercept be used to determine the factors of a quadratic equation? So if I know that my x-intercept equals 3, How can I work backwards to figure out what the quadratic is? What the factor is?
But hold on.
We know that our x-intercept is 3. We're going to work backwards. How can I write this as a factor?
-3.
Okay, so it's the opposite, right? So my factor would be the what? The factor is
The opposite of the x-intercept.
there you go. Okay, what if it was a fraction? Do we remember how to do with fraction?
Flip it, right?
What if I have x equals 1 over 3? What happens with that? Do we remember?
The bottom is the coefficient and the top is the constant, right?
There you go.
So what do you write back here?
You ask the question from the worksheet. No.
No, well, you have a question about the
Like, if you have a question about something, right here, then you answer it.
You answer it.
I mean, if you don't know how, if you ask somebody.
So this would end up as,
3x plus 1.
thank you. Not plus 1, Evan.
-1?
It's the opposite.
What? That paper you helped me with, remember when you explained that to me?
Yeah.
Okay, you gave me the wrong answer, and I wasn't going to question you because you were the teacher, and I was like, aren't you supposed to?
No.
Because you didn't.
I'm never gonna tell y'all.
I didn't get the paper wrong because I was like,
What paper?
You helped me, you're like, see, it's going to be 3x minus 9, so it'll be 3x plus 1, instead of doing the opposite.
Because yours was already negative.
No, it was minus.
You had a negative there. That's why I told you that.
It was plus, and you told me it was still going to be plus 1.
No, I thought it was a negative, and that's why I told you to make it a positive.
Well, I don't remember, but I was like, that's not right. I thought you're supposed to do the opposite, but then I was like, wait.
How do we know what a graph looks like? If it's a graph is a quadratic, it's called a what?
Square graph.
What is the shape? Parabola.
Doesn't work.
It's out of staples, probably. People have been using a lot of staples today. All right, how do we know that a function is a quadratic?
That's square. It's
in a graph of
The
4.
greatest exponent is a
2.
What's up, Martinez?
Hey, Trevor, how come you weren't in honors to begin with?
Because I was in regular, duh.
Like, why did
all right. These notes are going to require